Okay, let us watch the video first on nitrogen cycle while waiting the rest to join.
Nitrogen cycle. Nitrogen is the important essential element for all living organisms by the synthesis of amino acids, proteins, enzymes, etc. What happens if there is no nitrogen? Root systems and plant growth are stunted. All the leaves turn yellow, decreasing crop production, soil microorganisms, life becomes dangerous. In atmosphere, its concentration is 78%. The circulation or cyclic release of nitrogen from the atmosphere, physical or abiotic component, to soil, biodecomponent, and back into the atmosphere is known as nitrogen cycle. Nitrogen cycle involves various steps. 1. Nitrogen fixation. 2. Nitrogen assimilation. 3. Ammonification. 4. Nitrification. 5. Denitrification. Plants cannot utilize atmospheric nitrogen, so it should be converted into utilizable form, such as ammonia. 1. Nitrogen fixation. This is the first step of nitrogen fixation. Conversion of atmospheric nitrogen into ammonia for living organisms is known as nitrogen fixation. This process is carried out by leguminous plants, such as groundnut. Even some bacteria can fix atmospheric nitrogen. Examples of bacteria: Azotobacter, Clostridium, Rhizobia, Noster, and Anodina. 2. Nitrogen assimilation. The process of absorbing nitrates and ammonia into organic nitrogen is known as nitrogen assimilation. This organic nitrogen is transferred into animals' body when plants are eaten by animals. 3. Ammonification. The process of converting organic nitrogen into ammonia when animals die is known as ammonification. It is also known as mineralization. This process is carried out by some saprophytes like fungi and bacteria. Ammonia is also produced from volcanic eruptions and excretory products of animals. 4. Nitrification. The bacteria which is involved in nitrification is known as nitrifying bacteria. Ammonia is first converted to nitrites. Examples: Nitrosomonas, Nitrococcus. Nitrites are converted to nitrates. Examples: Nitrobacter. 5. Denitrification. Nitrates are converted into molecular nitrogen to nitric oxide, known as denitrification. In order to maintain the equilibrium of nitrogen in the atmosphere, bacteria which are involved in denitrification are known as denitrifying bacteria. Examples: Thiobacillus denitrificans, Pseudomonas denitrificans, and Micrococcus denitrificans. Problems with increase of nitrogen: acid rain formation, acidification of soil and lakes, increase in death of plants.
Okay, so I hope that video summarized up what we have learned for the past 2 days regarding on nitrogen cycle. Okay, there's also a video, other videos that I would like to share. Hold on, it's actually regarding on Haber process.
This experiment.
Okay. All right. So the next video is basically on Haber process. So what you see over here is basically they insert gas.
Another syringe holding precisely 3 times as much hydrogen gas, and waiting between them ordinary iron wool with an extraordinary job to do.
Yeah, the iron wool basically function as a catalyst.
Mix together as they travel up and forth over the hot iron. If it's working, this is where ammonia is created. This is the chemical reaction that should be happening here. 1 unit of nitrogen and 3 of hydrogen turn into 2 units of ammonia. The iron doesn't take part in the reaction, it's a catalyst. It helps the nitrogen and hydrogen bond together. Now it's time to find out if the experiment has worked. This pump sucks the gas out of the tubes through these yellow crystals. If there's ammonia in the apparatus, they'll change color to blue. It works, this time. But the equation reveals why ammonia is so hard to make. The double arrows mean the reaction goes both ways. It's reversible. Ammonia can turn back into the ingredients. The trick is to make the ammonia faster than it breaks down. This plant makes 800 tons of ammonia every day. That's enough to fertilize 7,000 football fields. It uses a system called the Haber process. The process means a giant maze of whining machinery and hissing pipes. To make ammonia, they must first make its ingredients, hydrogen and nitrogen. This is where the nitrogen comes from. There's not much to see on the outside, but on the inside, the machinery pressurizes air to separate out nitrogen from all the other gases around us.
Remember, I think yesterday I've told you, for nitrogen, we obtain it from atmospheric gas or atmospheric air. Then it will be like fractionate.
It makes hydrogen from natural gas, methane. Methane has the chemical formula CH4, 1 carbon and 4 hydrogen atoms. They extract the hydrogen by mixing the methane with superheated steam, H2O, at 500 Celsius. The tremendous heat splits up the methane and the water molecules and frees up the hydrogen. What's left over is carbon monoxide. Finally, the nitrogen and hydrogen come side by side down these pipes. The heart of the plant, where ammonia is made, it's called the converter. Just like the experiment in the lab, the converter contains iron for a catalyst, and it's hot. And it's at such high pressure that the metal wall must be made 11 centimeters thick. Outside, enormous steel bolts hold it together. Here's the problem. High pressure and cool temperature would make lots of ammonia, but it would take too long. So they have to heat the reaction up. That makes it go faster, but it also makes the ammonia break down quicker. Somewhere in between, there's an optimum, a temperature and pressure that works best. So the final stage of the plant starts with a compressor. It pressurizes a mixture of nitrogen and hydrogen gas to about 200 times atmospheric pressure. But the compression has another effect. It also forces the temperature of the gases up to about 350 Celsius. That makes the nitrogen and hydrogen gas molecules split up. Inside the converter, a hot iron catalyst is waiting for the nitrogen and hydrogen. They react together at its surface to make ammonia. The reaction also releases heat, keeping the temperature just right for maximum production, about 500 Celsius. But even so, some of the nitrogen and hydrogen is still left over, so the mixture that passes out from the converter isn't pure ammonia. The very last stage chills the mixture's temperature down, so that ammonia condenses out as a liquid. It's drained off from the bottom. Meanwhile, the nitrogen and hydrogen float up to the top and get sent round a loop back to the converter. So, to make ammonia from the air by the Haber process, air is first liquefied under pressure, and the nitrogen is separated out by fractional distillation. Hydrogen is extracted from methane at high temperature. The nitrogen and hydrogen are combined to make ammonia. This is done at high temperature and pressure with an iron catalyst.
Okay, all right. So that's it for Haber process. And I guess yesterday we have learned about the production of ammonium nitrate. Okay, ammonium nitrate and also urea. Okay, so today we are going to continue the last part of chapter 6. So a bit fast. I already uploaded your new chapter, chapter 7. And chapter 7 is basically the last topic that you will learn for inorganic chemical processing. And I think next week we are going to take a break for lecture. Mostly, 3 days we are going to have a presentation. So of course, for Tuesday, group 1, 2, and 3. And then Wednesday, we are going to have group 4 and 5. Okay. And then day 3 on Thursday. Okay. We are going to have group 6, 7, and 8. So at that time, the same time as our lecture. So next week, we are going to have only presentations, right? Okay, so for today, we are going to continue with the production of nitric acid. Okay. The most important single use of ammonia is in the production of nitric acid. It is important, meaning that if you want to produce nitric acid, part of the required raw material is ammonia. And you know now that if you want to produce ammonia, you need nitrogen plus hydrogen, and all is actually integrated. I can ask you a question like, given that methane, I give you like methane, and then I want to produce at the end nitric acid. So how actually you can, summarize the process? So it will be a combination, because methane can produce hydrogen gas, and then from hydrogen you can react it to form ammonia, and from ammonia it will perform Ostwald process to produce nitric acid. So in reality, later on during exams, I can ask you a combination of different chapters, what you have learned so far, integrate into one type of question, right? A mixture of 1 part of ammonia to 9 parts of air is passed over a platinum gauge catalyst at 850 degrees Celsius. whereupon the ammonia is oxidized to nitric oxide. Ammonia solution is also used, okay, as a universal indicator that could be used to test the different gases that requires a universal indicator solution to show the gases were present. In this case, you will react ammonia with oxygen to produce nitrogen oxide, okay, plus with water. The catalyst is essential as the normal oxidation or combustion of ammonia give the nitrogen and water, dinitrogen. So dinitrogen and water, and the production of nitric acid is an example of kinetic control. As the gas mixture cools, okay, from 800 to 200 or 250 degrees Celsius, the nitric oxide is in turn oxidized by the excess of oxygen present in the mixture to give nitrogen dioxide. This is reacted with water to give nitric acid for the use in the production of fertilizer and also explosive. So earlier on, the process is basically by reacting ammonia with oxygen, which eventually produce dinitrogen or probably nitrogen oxide plus with water. And what happened is that nitrogen oxide can further, okay, oxidize because you have a presence of excess oxygen to form nitrogen dioxide. And from nitrogen dioxide, it will react with water, okay, to produce nitric acid. This is basically the reaction, okay. You have ammonia reacted with 8 volumes of oxygen, okay, and platinum gauge is used as catalyst. Temperature used during this process is quite high, 800, and then it goes into the oxidation chamber where it converts the product produced, which is nitrogen oxide. So this doesn't mean no. This actually indicates that nitrogen oxide. Nitrogen oxide reacted with the excess oxygen to produce nitrogen dioxide, and nitrogen dioxide will react with water, okay, in adsorption tower to produce nitric acid. Okay, so after this we can see the video how the Ostwald process or the production of nitric acid can be performed. The PID, okay, or the flow diagram of typical nitric acid plant is as follows. You will see over here, okay, you will have a compressor expander, okay, where air is going in, okay, and when it goes inside, right, you will notice also that ammonia is being put over here, okay, ammonia being put, and then you have like oxygen being put also. So during this process, okay, it will produce nitrogen oxide. Okay, so nitrogen oxide goes into this waste heat boiler. This is where the further oxidation process happen to produce nitrogen dioxide. So nitrogen dioxide will goes into this cooler condenser, which then react with water to produce nitric acid, okay, in the adsorption tower. The flow diagram of high strength nitric acid production from weak nitric acid. So this is actually slightly different because earlier on, the Ostwald process is the production of nitric acid from ammonia and also oxygen plus with water. But for this one, you can produce, this is more of like you want to concentrate your nitric acid. Okay, perhaps the nitric acid that produced in the earlier stage is quite dilute or weak. Then what you need to do is you need to do hydration. Okay, so you will react, I think, less concentrated nitric acid with sulfuric acid. Okay, and it will goes into a bleacher, where next it goes into the condenser. It will form a strong nitric acid. Strong nitric acid means that higher concentration of nitric acid, probably 80 to 90% of percentage concentration. Apart from nitric acid, for nitrogen-based industry, you have also the production of sodium nitrate. Okay, the sodium nitrate is normally used as a fertilizer, explosive, and also heat treating mixes, and sometimes used also in tobacco additive. So those who are smoking, then you know that you're also inhaling, or part of the chemical contained in your cigarette is sodium nitrate. So the production is basically from mining process, okay, because you will get these nitrate minerals or nitrate ore, okay, and you can also produce sodium nitrate from synthetic process by reacting caustic soda with nitric acid, because at the end you will get sodium nitrate plus with water. Okay, sodium nitrate is also synthesized industrially by neutralizing nitric acid with sodium carbonate or sodium bicarbonate. Okay, so similar thing. You can also get sodium nitrate by reacting nitric acid with sodium carbonate or sodium bicarbonate, because both will actually produce the same thing, sodium nitrate. It's just that here you will have a different amount of carbon dioxide gas produced. All right. Apart from that, sodium nitrate can also be produced from various chemical reaction. For example, if you have ammonium nitrate reacted with sodium hydroxide or caustic soda, it will form the same products. Ammonium nitrate reacted with sodium bicarbonate, okay, you will get the same thing, sodium nitrate with ammonium bicarbonate. And yeah, you can also react urea with ammonium nitrate reacted with sodium carbonate to produce sodium nitrate plus with carbonate. Okay, and last but not least, we also have the production of potassium nitrate. So the production of potassium nitrate is basically by reacting magnesium nitrate plus with potassium chloride plus with water. So what happened is during the mixing, it will be raised to high temperature, okay, and it will form a crystal. So the product that you will form is basically you will form potassium nitrate, because potassium chloride reacts with magnesium nitrate. It will form potassium nitrate plus with magnesium chloride. So this is actually the byproduct, and you can actually separate them because the product will form in the form of crystal powder. Okay, so crystallizer is actually function as the purification step, because you will collect it, you will recover, and then after that it will goes into the condenser again, and just for recrystallization to make sure that the purity is high. And finally, you will get a dry potassium nitrate in the dry products. So of course, the uses of potassium nitrates, it can be used in fertilizer, explosive, ceramics, and also heat treating salts. Right. So I believe maybe we can have a look on the production of nitric acid from Ostwald process. Maybe I can share you the video.
About 60 billion tons of
Okay. Stop share. All right. So I hope you can see the picture. Can you see the picture?
Yes, doctor.
Right. So thank you.
Of nitric acid are made each year worldwide. Most is used to produce ammonium nitrate fertilizer. Ammonium nitrate is also used in explosives. Nitric acid is used in the making of nylon and for polymers that are used in sports clothing and swimwear. The raw materials for making nitric acid are ammonia and air. In the converter, nitrogen monoxide is formed. This is cooled and reacts with more air to produce a mixture of nitrogen dioxide and dinitrogen tetroxide. These gases are absorbed in water to produce nitric acid. In this plant, liquid ammonia is fed to the evaporator here. Ammonia is mixed with air here and passes to the converter. This is the absorber. Liquid ammonia is fed directly from the ammonia plant, which is close by on the same site. It is evaporated in this vessel using heat from hot water produced later in the process. Air, the second raw material, is drawn from the atmosphere and compressed to a pressure of about 5 atmospheres. Filters are used to remove oil and dust from the air, which could poison the catalyst used later. The streams of air and ammonia are mixed here and passed to the converter, also called the burner. This is just the top of the ammonia burner. Inside the burner, the gases produce heat as they react to form nitrogen monoxide and steam. The reaction is catalyzed by a cause of platinum and rhodium. Catalyst causes are changed every 3 to 4 months. The woven metals become poisoned and returned to the manufacturer to be recycled. The reaction in the converter produces heat. The gas stream leaving the converter is cooled by water. This produces steam, which is used to drive a generator. In the gas stream, the nitrogen monoxide is oxidized by excess oxygen to a mixture of nitrogen dioxide and dinitrogen tetroxide. The mixture passes to the base of the absorption tower. The gases rise up the tower and through a series of slotted trays. Water runs down the tower. A reaction occurs to produce an approximately 69% solution of nitric acid. This is the equation for the reaction. The reaction is exothermic. It produces heat. The blue pipes contain water that is used to cool the acid stream in the tower. The production process is monitored and controlled remotely from the control room. Most customers require the 60% or 69% acid. About half the nitric acid is used on site and half transported by tanker.
Okay. All right. So basically, you have seen how we can produce nitric acid. The same thing as what we have explained earlier in the lecture. Okay, so basically today perhaps I can assign you with one homework for you guys to do. So the part of the homework that I want you to do is actually to discuss the types of um, nitrogen-based product that we have learned so far, starting from ammonia, okay, ammonium nitrate, urea, and then followed by nitric acid, and the rest is actually sodium nitrate and potassium nitrate. So basically what I want you to do is like write a summary. Okay, you are free to make it in the same thing like a graphic poster that you've done earlier before this. You can summarize all the process, and if, like for example, you can find also the other methods of producing this type of chemicals, you are also welcome to discuss it there. Okay, so I guess I'll give like until Saturday for you guys to submit this this homework. So as I said, the homework is basically on summarizing the types of nitrogen-based chemicals that we have learned so far, starting from ammonia, and then nitric acid, okay, urea, sodium nitrate, ammonium nitrate, potassium nitrate, and also yeah, that's all, I guess. Okay, so all right, I actually have uploaded your chapter 7. Right, so still have sometimes maybe we just start a little bit on chapter 7 before we call for the day for today. Let me share the slides. So far, is there any question that you want to ask? Ada apa-apa soalan? Anything regarding on the chemicals that we have learned? Okay, all right. So today we just go through on the introduction part of sulfur. The last chapter is basically on sulfur-based industries. Talking about sulfur, anyone have some like idea or like what kinds of food or anything or compounds that use sulfur in the daily life? Siapa-siapa yang boleh bagi cadangan? Or anyone have some idea where does this sulfur-based chemicals can be found? I think I've quite some time I've never called students, so maybe can call Kugan Morgan. Are you there? Kugan. Just keep quiet. Okay. Lim Boon Kit. Are you there? Boon Kit? Same. Silent. Maybe enjoying lunch, I guess. Saya panggil yang berpuasa lah. Nur Azlina, are you there? Nur Azlina?
Yes, Doktor.
Ingat tadi senyap bau nak cakap tengah live cakapnya. Okay. Alright,
Yeah.
Azlina. So
Yeah.
can you give examples what types of sulfur-based chemicals that you can find in daily life or that you can find around you?
In cosmetic,
Kosmetik pakai sulfur
ada.
Oh yeah. Patut nampak kuning je. Okay. Alright. Other than that, apart from cosmetic, really cosmetic have a okay. I didn't know about this. Any other things? Food maybe?
Tak sure lah, Doktor.
Not sure. Okay. Never mind. I can ask another person. Nurul Azrin Shafina. Azrin Shafina? Ada kat situ tak? Azrin Shafina pun tak ada. Tengah yang yayuk Nurul Fadila. Nurul Fadila pun tengah ayah-ayuk agaknya. Okey, panggil budak lelaki lah pula. Think I've called like Google and Bungkit respond. Tengok Mukri lah, Mukri. Mukri ada tak?
Ada doktor, ada. Saya ada.
Oh, Mukri bagus. Hari ni dia puasa dia. Okey. Gurau je. Okey. Alright. Apa contoh sulfur based chemicals yang Mukri boleh bagi? Yang boleh nampak. I mean, dalam kegunaan seharian.
Boleh nampak Maggi mungkin.
Maggi?
Bukan.
Maggi? Oh, okey.
Ni
Maggi ada sulfur
tahu lah doktor. Saya macam
Oh, dia Mukri dia nampak kuning aja dia cakap semua ada sulfur. Okay. Thank you very much for trying. Basically,
Okay.
another simple example that you will see is durian. Nah, so durian, if you notice, the flesh, dia punya isi durian tu, have you ever wonder why it is yellow? Actually, it contains sulfur, very high amount of sulfur. Even if you burp also, the smell is unpleasant. The reason why is because if you actually eat durian, then you are eating too much of sulfur, and you know inside your stomach you have acid. Acid is actually like function to digest the food and everything. So the acid, hydrochloric acid, diluted hydrochloric acid react with the sulfur containing flesh from durian, and it will produce hydrogen sulfide. So hydrogen sulfide is actually quite unpleasant smell. That is why I think when you burp, smell is not really good. So those who are wondering like hydrogen sulfide, when I said hydrogen sulfide, very corrosive gas, the smell is like smell of durian. Okay, so that is why during durian season, don't eat durian too much. Nanti kalau terkentut, boleh terkoyak semua. Okay, it's very corrosive. Okay, alright. So apart from that, what other types of sulfur-based chemicals that you can find? Basically, if you heard about like the use of sulfur in, I mean, as a barrier, or people sometimes call it as belerang. In Malay, we call it as belerang. We use sulfur with the hope that if you go, I mean, camping, or if you go to your nursery or what, you want to prevent that area from any dangerous species like snake and whatnot. So you will like put some sulfur on the ground, okay, and actually hoping that this dangerous species wouldn't come closer to you. Okay, but that's actually I think a myth lah. I mean, you've heard about from the old folks saying that okay, if you apply belerang and cleaning your house, and then snake wouldn't come. But eventually, actually, it didn't work. So sulfur doesn't have any like how to say a hot properties that when it touch to you it become hot or what. So basically the theory of applying sulfur or belerang just I think around your house or what is actually didn't work lah. Probably the only thing is it can actually repel insects but not like snakes or other things lah. Okay. Alright. So kalau ular datang buat apa? Telefon bomba, telefon jepam. Solve the problem. Okay. Alright. So apart from that, where you can see, sulfur containing products, you can see a lot. Of course, in the lab, like sulfuric acid. The sulfuric acid being used as a part of chemical synthesis and others. Okay. So today we are going to start with chapter 7. It's basically on sulfur-based industries. What we are going to address in this chapter is basically introduction of sulfur, recovery and mining of sulfur, okay, and then the production of sulfur and sulfuric acid, right? So don't be confused. You have a different spelling of sulfur. You have SULFUR. This is actually a US standard. You also have like SULPHUR, sulfur. Okay, this one is a UK, a more English style version. So it's the same when you do or when you write characterization with S for UK style and Z for US style. Okay, right. So sulfur is the 10th most abundant element in environment. It has a yellow, bright crystal solid with a tasteless and odorless non-metallic element. Mostly stored in underground rocks. You have learned in chapter 4 about sulfide ores. Okay, for example, like PBS, lead sulfide, mercury sulfide. It also presents in protein, okay, amino acids, vitamins, and also enzymes. The uses of sulfur, it is part of the component for black gunpowder. Okay, it is also a vulcanization for natural rubber, because you will see sulfur is part of the cross-link bridge that forms in rubber. If you want to make the rubber become harder, so you just react natural rubber with sulfur, and this process is known as vulcanization. It will strengthen the rubber, and then it can also be used as fungicide and insecticide. Apart from that, it can also be used to make fertilizers. Okay, used also to produce sulfuric acids for wet battery, battery basah. This one is actually for cars, but I guess these days it's quite rare to see wet batteries. Most of the car now use dry battery. Okay, after 2 years we just replace. But for wet battery, you can actually, just replace the electrolyte only. Okay. So fireworks, paper, and some medicine also use sulfur. And sulfur dioxide is a cheap and excellent refrigerant, and once was used, okay, widely in home refrigerators before it was replaced by freons. Okay, so natural sources of sulfur, it can be found from deposits. Of course, this one basically from ores. You can also find sulfur in sour crude oil and natural gases. Okay, sour natural gases. Sour means acidic natural gas. Well, of course, for sulfur, we have this sulfur cycle, but I think I'm not going to go through this today. Okay, perhaps tomorrow we will start or continue with sulfur cycle. The same function actually as nitrogen cycle. The reason why is actually it converts, of course, sulfuric acid from acid rain into sulfur-containing chemicals. Meanwhile, in nitrogen cycle, you will observe that nitrogen gas will be converted into nitrogen-based chemicals. So for sulfur, it will be different, slightly different, because you will have the production of sulfur dioxide, sulfur trioxide, and then when it reacts with water in the cloud, it forms acid rain. So acid rain actually will start or initiate the production of sulfur cycle. All right, so I believe we can adjourn to till here. Okay, and before that, is there any question that you want to ask regarding on the production of nitric acid, sodium nitrate, and also potassium nitrate, apart from the introduction for sulfur-based industries? Ada soalan atau tak ada? Okay, and forgot to tell you that I have uploaded your quiz in the e-learning. So I think I put the due till 10 p.m. because I understand think ada lab, and then you also need to iftar, breakfast, and perform Tarawih prayer. So I put it until 10 p.m. Hope the time is quite sufficient. Okay, so without other things, I guess I would like to thank for your kind attention. Thank you very much. Wish to see you tomorrow morning, 8 a.m. And have a good day. Thank you very much. And Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
Ada.
You're welcome.
Thank you, Doctor.